the resources in my first year was really limited. The lab was in the basement, the student don't have a window, and I would say pretty bad for the first year. Sometimes, you go to the point that you keep submitting grant, but you never get the award, you never get the grant funded. From I started at UConn until now, maybe $30 million.
Wow.
As a professor, we're actually not very different from a CEO. I play a lot of soccer. I like soccer. I've been playing since I was a kid.
Hi guys, welcome back to Husky. My series. I'm very honored to interview a very special guest, my advisor at University of Connecticut, Professor Thanh Nguyen. So Professor Nguyen recently achieved the rank of full professor, the highest milestone in academia, and he has built a very big and successful lab at UConn with more than 30 members, secured a lot of fundings, and even started the startup companies based on the technology he developed. So today we're gonna listen to his journey and also the challenges he faced and the lessons he learned along the way. So thank you so much for joining me today.
My pleasure. Thank you.
First of all, congratulations on the promotion to full professor at UConn. That is a very big achievement. So how do you feel to reach to that milestone?
Thank you. I think that's a good promotion, and it's encouraging to me. It is showing that I was somewhat successful in my career. But at the end, it's just a title. I think there's so many other things that it make me more excited, and I'm still doing the same things as every day I'm doing. So not very different from what I'm doing and what I'm feeling.
Yeah, sounds great.
Yeah.
So I think a lot of students would be very interested in hearing how your journey began. So can you tell me briefly your journey from a college student to a full professor today?
Yeah. I started in Hanoi, Vietnam, as an engineering student studying engineering physics. And at the time, I wasn't sure what I'm going to do. Pretty much just studying as hard as possible. I usually try the best in whatever I committed to do. But more and more, I figure out that there's a really interesting area of research and study that I want to do. That's the area when we can combine engineering, physics, chemistry, biology, on pretty much all of the other disciplines together to work on some big medical problems. And I was lucky to be selected by Princeton University. Graduate program in mechanical engineering, and then I went there. I was recruited to a new research group working on nanomaterials, but for biological applications. And then I found this wonderful lab at MIT. They're really doing like a really impressive translational research. And that is exactly what I really want to do. And I met with my former postdoc advisor, Professor Bob Langer, really inspired by his wonderful, terrific career and his mentorship and also his personality. And that is when I know what I want to do in life for my career, for what I want to become. And that is why I decided to go to UConn as a professor after my postdoc, working on this field of biomaterials, bioengineering, and just enjoy working on that so far.
Yeah, sounds wonderful. So when you were a student, did you always know that you wanted to become a professor, or did you just develop over time?
I think it was developed over time, but I do like the way that there's a daily interaction with the people who's younger than me, who maybe have not been exposed to the knowledge that I had, but they always excited and to learn and passionate to pursue something that had a big impact on human life. So that always, something that I think that why I became a professor, because I like to have such an interaction.
Yeah, that's very inspiring. So for people who may not be familiar with academia, so how long does it typically take to become a full professor?
I was in UConn for 10 years until I got the full professorship. I would say it depends on many things, many factors. Usually the process is you study as an assistant professor. After 5 years or 6 years, you submitted your package to be promoted to a tenure, officially tenure associate professor, and then after that you move to the full professor. So depending on how much the scholar activities that you perform, how much you becomes reputate or have a good reputation in your field, and how many students you graduate. So all of that factors would be accumulated and considered by a committee who would select you to be promoted to the next level of professorship. I would say typically it's about 11 or 10 years.
Yeah, that's a long journey. So looking back, when you first arrived at UConn and started building your lab, was it difficult? How did you build your lab from the scratch?
Yeah, my lab at UConn when I started was in mechanical engineering, in the basement of a mechanical engineering building, and so it wasn't designed as the biotechnology lab or biomaterials lab. So we did not have a fume hood, we did not have a cell culture hood, but I was lucky that some of my colleges they have some sort of a chemical hood that I can temporarily borrow them to perform some chemical, the chemical research, and then some other professor have some cell biological hood from the chemical and biological engineering. So that was allow me to, use and perform some sort of a cell work. But it was the resources in my first year was really limited. The lab was in the basement. The student don't have a window and pretty, I would say pretty bad for the first year. But fortunately, the school opened a brand new lab for bioengineering research, and that was at the end of 2017, at the end of my second year here. And then we moved all the lab to, this building, this beautiful building. When you have all of this window, the student working in a very open environment, talking to each other every day, and was much better lab that we have now, and that was really a big change, a big positive change. From that, I think we was making a lot of wonderful science from the lab.
Yeah. So, what was your biggest challenge at that time?
As a professor, I think the challenge is you have to be really doing a lot of many different things at the same time. You have to supervise the students, you have to teach, you have to do services, you have to review papers for journals, you have to review grant proposal for NIH, NSF, DOD. At the same time, you have to be getting the funding to support the lab, and in the U.S. specifically, I think that becomes a very important job and task, that you have to make sure that you sustain the funding, and then at the same time you also recruiting students and postdoc by yourself, building the lab and doing the research. So many different things. That is really the nature of academia, and you have to be ready for that. So probably that the most challenging things. But once you can recruit good students, postdocs, and getting your first grant, be familiar with the work, I think everything becomes easier. I wouldn't say easy, but becomes easier.
Yeah, that's a lot of work, I could imagine. So was there any moment that you thought oh, is this much harder than I expected, or do you have any moment that you feel like you doubted yourself?
Yeah, I think we always have that moment. I never doubt this is this is a job that I don't like because I always want to be a professor. But sometimes, maybe especially in the grant application, there's so many things that is unpredictable, and sometimes you go to the point that you keep submitting grant, but you never get the award, you never get the grant funded, and it could be frustrating because you don't have enough money and funding to support your students, and the postdocs, people surrounding me, could be suffer from the lack of grant, and for me that's probably the most dangerous things. Yeah.
So how do you stay motivated during those difficult times?
I think you want to be surrounded by good people, and for me, I think my students, my people surrounding me, keep supporting me, and they probably the source of motivation that keep me on track of working and keep submitting grants and getting more funding. They really the source of what I want to do now. Just keeping working on the stuff that can bring in the resources for them, and they producing wonderful science, which keep me really excited to work on the stuff that I committed to work on.
Yeah. So from the scratch, your lab now has grown very big and achieved a lot of success, right? And there are more than 30 people in your lab. So how do you manage that many people, and do you spend enough time for every single one of them?
Well, yeah. I mean, I think as a level of a PhD student and a postdoc, for the more senior postdoc and PhD students, they become more independent, and they can be self-motivated and also be able to learn the stuff doing research on their own. My work is mainly to supervise them in the microscopic level. I'm not in the lab in the daily basics, and so I talk with them once every week and maybe twice every week, and that would keep me on track of what they're doing, how they're progressing on their work. I would say that I rely on a lot of people on my lab in order to manage the lab. We have a really good lab manager, and people in the lab understand that we work as a team, so they help each other, they monitor each other, and so that's the way that the lab is functioning, and it doesn't need me to be physically presenting the lab in the daily basics, and I don't want to do that because I think micromanagement is not my style. I think that just reduce the productivity rather than increasing the productivities. I think I want them to be more independent and have their own freedom to develop ideas, work with other people in the lab. For younger PhD students and the new members of the lab, they need more help. But usually the senior people would be the one who directly teach them the stuff in the lab and guide them through that. Probably only the first 3 years of my career I would spend a lot of time in the lab because that's when I had the first couple of PhD students who I need to directly teach them, show them the techniques, the skills, and the experimental processes. But after that years, I think they become more senior. They can teach the next generations. So that's how the lab is advancing and functioning, and have a lot of people, but I can still manage them. And they always can, email me or call me. I'm very available to my students. So there's no matter that how many people I have, I would be able to make sure that they had the support that they need.
Yeah, that sounds amazing. So what makes you proud of your lab?
Yeah, I think of course, is the science, but also the people in the lab. Many of them have succeeded, to when they move out of the lab, they succeeded to move to a really big position. We have a postdoc, now is a professor in China in the top Viking University, and we have postdoc come back to home to become vice provost. We have PhD student advance to the next academic level, being a postdoc in MIT, Stanford, getting the NIH grant for their postdoc, and we have the PhD student move to a big industry like Eli Lilly to work in the industry. So in the lab, there's we have a lot of people, that advancing into both academia and industry. Some of them also work in my startup right now. My master's student now is a lead engineer of a startup that I founded, and become a significant person there. So, I think that's the really things that I'm really proud of.
That sounds wonderful.
Members moving up to a really big position in both industry and academia.
Yeah, that's wonderful. So can you tell us about the research that you are working on right now in the lab?
You probably know this. You're one of the students. But yeah, okay. In general, we are a biomaterials group, and we trying to use a very safe and biodegradable medical materials and transform them to to special forms, shape, structures, or some exciting electroactive materials, so that we can use them in many medical implants for many medical applications. So one of the research area is tissue regenerative medicine, so in which we use materials, safe and biodegradable materials, which which it was transformed to perform some electroactive property that can be used to promote the regrowth of bone, cartilage, skin. And then the other research area is drug and vaccine delivery, in which we make this tiny skin microarray patch that we can just stick on the skin, peel it off, and then you have all of the vaccine doses and all of the drug doses built inside the skin, for multiple and longitudinal delivery. And then we're working on also a medical implant that it can degrade by itself, so that when you implant into the body, it can sense a lot of different important physiological signals in the body, but then you don't have to remove it, which is invasive to the body, because they can degrade by themselves. So those are the three big research area in the lab, but it's based on the functional biomaterials that we developed.
Yeah, I could see a lot of projects ongoing in our lab. So how do you think the research you are doing could impact the society or improve the people's lives?
So that's always the motivation in all of this research that we're doing in the lab. We are bioengineering groups, so any technologies that we're working on, the final destination would be the clinical use and implementations. We have acellular synthetic polymeric scaffold that it can be implanted into the bone or cartilage defect to regrow the damaged cartilage in the osteoarthritis patients, and that's a big deal.
Yeah.
It reduced pain, it improved the tissue healing, and it treated the disease that it wasn't curable before. We also make implant device to facilitate the delivery of the drug through the blood-brain barrier for the treatment of the brain cancers. And then we're making electronic sensor that it can monitor the internal intra-organ pressure, like the joint loading or abdominal pressure, and then it degraded to to avoid the invasive removal surgery. So there's a few examples to show you how impactful this work are, because they all gonna help the human being, gonna treat disease, prevent disease, and maybe monitor diseases. So they have a huge impact on human life.
So to do research, of course, we need a lot of resources and funding to keep the research going. And I know that you are one of the top funded researchers at UConn. Do you remember how much grants or funding you got over the years?
How much? How many grants? I can't remember.
Maybe the money?
Yeah, maybe the total is roughly, from I started at UConn until now, maybe $30 million.
Wow,
yeah,
that's a huge number. So what factor do you think contributed to the success of getting grants?
I think in the optics, I think, of course, you need to have a really high quality publication, a research that is well recognized by the people in the field, because those people are the ones who are going to review your grant. So everything is peer review, and so you have to have that foundation. The quality of your own research is really the foundation. Working on a big impact, big problem, certainly is make it significant to convince people to fund your research. But besides that, you need a good skill in writing, in communicating, and that's why I always stress on my students that the science is about communications. You're writing a piece of paper basically to communicate your findings, your technology, convey them to the audience. So you have to write it in a good way, easy to understand, simple enough, but still thorough and comprehensive. So that communication skill is very important, and it needs to be built up along the way that you're writing, grants. Maybe at the beginning you're not good, but then slowly you will becomes better, and then become an expert.
And I know that you are running 2 startups companies based on the technology you developed in the lab, right? So can you tell us how those companies got started?
Yeah, the final goal of this, research is to create something that it had a real impact on the human life, and to do that, you need to bring it to the commercial stage, in which you can mass produce the product and get it to the market, get it to the hands of the patient. And in order to do that, you need industry to be involved. And either you can license the technology to a big company, or you can found a startup who can develop the business plan, commercializing plan to bring your technology towards the clinical use and bring it to the market. A lot of these big companies, they sometimes they license it, and then they don't do anything just because they want to just keep the main product that they already have to be more profitable. And for me, I don't, when we have this technology and we have a good people who really passionate on bringing them to the market, I would open the startup and get that people to be the leader of the startup, so that they can do from the scratch, raising funding and do other stuff to with a good business plan, with a good commercializing, good manufacturing plan, regulation plan to bring that to the end. And the startup journey is really fun because you learn a lot. A lot of things are very different from academia, but at the same time sharing the same principle. You need to have a hypothesis on your business model, and you have to be a really good team. So, it's always learning. That makes me excited to have it for both purposes, for the sake of learning, but for the sake of bringing my technology towards the ending goal, which is in the hands of patient.
So how is it different from running a startup and compared to running a lab?
You know, it's quite similar. You have to be a good team, and you know who is good at what, which area, and you have to communicate with them well by understanding all of this concept in the business, and of course, very similar in the way that for startup and for the lab, the funding is really, you know, it's the life of that. Problem. You have to sustain the funding in order to support the people in the startup and also the people in the lab. So, as a professor, we're actually not very different from a CEO that keep raising the funding, pitching on the technology, pitching on the startup products, and bring it to the next level of the production. Of course, in the business, the hypothesis is different from the academic lab. So, you know, it's a different way to think about the problem. But in terms of management, fundraising, they're pretty similar.
So now you became a full professor. So I'm curious, what's your day-to-day looks like?
Oh, okay. That's a good question. I'm a normal guy, so not very, you know, I'm not very different from other people, but technically, you know, I would wake up, work on my email a little bit, and usually I try to go for swimming, like an hour in the morning, and then I go back, I work again on a lot of stuff. And then in the afternoon, I would do exercise again. So and then I go back, have dinner with my family, with my kids, and maybe do some review of the papers that I'm an editor on, and then that's it. That is pretty much my daily routine for every day.
I can see you have a very busy schedule, right? So outside of work, what do you enjoy doing? You know, you mentioned about swimming, doing exercise. Anything else? Do you have any other hobbies? Or?
I play a lot of soccer. I like soccer. I've been playing since I was a kid.
That's so cool.
And so it becomes my habit, and every day I have to do exercise. Usually when I was a kid, I played soccer every day at 6 or 5 the times between afternoon and evening. But now, because I'm too busy, so I usually play like maybe twice a week or once a week with my friend. But I keep doing that because that keep my physical condition good, and that can help me a lot in terms of working on a lot of this research.
That's pretty good. So you achieve a lot of success. So what does your family think about your achievement? Are your children aware of what you are doing? I took them to the lab a couple of times. I think they met you before, and they enjoyed it a lot, and they understand my job. And I'm lucky that my wife, my kids are really supportive of what I'm doing. They're really proud of it, and that's make me even enjoy it further. We all feel good about that. So looking ahead, do you have any goals that you want to achieve in the future?
Of course, a lot. My passion is always bringing my old technologies to the clinical use. And maybe not only that for human use, but also for other, for the other applications, like the microneedle vaccine patch. Maybe that could be used for a pet application for animal health. It doesn't need to be a human health, but at least it needs to create a real impact. In the lab now we have more than 10 research projects, and every day we keep doing trying new ideas. And so I'm always passionate on really making something that is impactful and have a real application, and always try to translate them to the commercial use and the clinical market. So that's always my goal.
That's wonderful. Thank you so much for sharing your journey and experience today. I think many students will find your story very inspiring. So I really wish you continue success in your research and in your life as well.
Thank you. Yeah, great.